Hello guys, how are you? Today we will see that what is search operation in array. Okay, so we will learn two types of search operation, that is linear search operation and another is binary search operation. Okay, so if you don't have the concept of array, you can check my playlist. I'll provide you in the video description and provide you the timestamp so you can jump any section of the video. Okay, we can see that what is search operation. You can see here I create a array that have that have six element, and those are the index number. Array index number starts from 0. Okay, and the end element index number is n minus 1, that is 6 minus 1 5. I want to find the 14 number. Is it present in this array? If it is present in this array, so what is the index number? Okay, so find mm, we solve this problem. Okay, so you can see here a table, that is binary search and linear search. You can see here first row is time complexity. Binary search time complexity is log of n. For example, if n is equal to 10, so what's the value of log of 10? I mean log of 2 base 10. It is approximately 3.32 something. Huh? And what is the time complexity of linear search? That is order of n. I say that my n is 10, so order of 10 means 10. Okay, so linear search is three times of three times greater than binary search. Okay, so here the time complexity is minimum in binary search. Second one is record the sorted data, and linear search is work with unsorted or sorted data. So if I perform the binary search, we must have the sorted data. So what is sorted data? Sorted data. Already I search here in the Google. You can see over here a array, and the first element is 1, 2, 4. The first element is less than the second element. Here you can see the 2 is less than 4. Here 4 is less than 5. So this is the getter wise sequence. This is the sorted data. And here you can see the unsorted data. Here the all numbers are haphazardly stored in this array. Here you can see 1 is the smallest, I mean 1 is the minimum value in this array, but it is in the middle of the array. Okay, so this is a unsorted data. So binary search only work on sorted data, and linear search work the on both unsorted and sorted. And binary search is complex. I mean the program is complex, and linear search is simple program that have used we will use only one for loop. Here you can see use case, the searching for sorted data, and here you can see the small data. Binary search is about for the large big database. If I have a big database and huge amount of data, you can use the binary search operation. If I have small data and that is unsorted or sorted, you can use the linear search. Okay, so now I will write a code. I use Bibc++. Okay, so you can use any code editor. Okay, here I write a boilerplate. Here you can see this is the header file and this is the main function. Okay, so here I add another function, that is here I add another header file, that is stdlib. Okay, so this is for exit function, this header file for exit function. Okay, so first of all we see the linear search. Okay, so see here, for example we have a unsorted data. Previously I said that the linear search can perform in sorted or unsorted anything data. Okay, so here I take a unsorted data. Okay, here have 1 2 3 4 5 elements in this array. Okay, so in linear search operation we check, for example we want to found the 3. Okay, we want to found 3. So first we compare with the zeroth index. Is this 3? Not. So we check the next one. Here you can check. Is this 3? Not. So then we check the next one. Is this 3? Obviously not. So then we check the next one. Is this 3? Yes, right. So here we found the 3 element. Then we print the index number of this box, that is 3, and we print a statement, that is we found the element. Okay, if for example I remove all those, for example I want to found the number 7. Number 7 is not have in this array. So when I check all the comparison, we don't found the 7. Here we don't found the 7. So then we print a statement, that is we don't found the number 7. Okay, so here we have a two condition over here. Okay, so let's go, we write in this code. First of all we declare a array, that is here you can see 5 element in this array. So here you can write 5 element. And what is the element? 2 5 1 3 4. 2 5 1 3 and 4. After that we run a for loop, that is in I is equal to 0 and I less than, how many element we have here? 5 and I plus plus. And in the for loop we write a if statement, and array array square bracket of I, if it is equal to, here I write, here I input a number from user. Here I write a printf statement, enter number which you search, SEARCH, nice. And here I declare a variable, that is int our target, target. Here I use a scanf for user input my data, %d and ampersand of target. Done. Successfully we take user input and we store the data in, we stored the data in target. Here you can write target when my array value is equal to target, then print. What we will print, what we will want to show when we found the element, we give a statement over here that yes, found the number. Okay, and here and must here we write a ex, exit for closing our program. Why I use here exit function? Because when I get my number that I want to found, I print this statement that is yes, we found the number and then close the program. If we don't found the program, what we will print? We print after the for loop that don't found the number. If I run this code, you can see if I write for example here you can see enter number which you search. I want to search number 3. Enter. Yes, you can see over here. Yes, the number is found. Okay. So if I write here 7, you can see oh don't found the number. I can modify over here. I write here index number is percent d. So what is the index number? So here you can see I is work for the index number because the loop will continue to 0 to 5. Okay, index number. So here I write I. Okay, if I run it you can give here 4. You can see here the index number is 4. Here you can see if I write here 7, oh no, the number not found. If I write here 1, you can see the yes, the number found and index number is 2. Now we will see that I'll provide you this code. Okay, so now I open a new file and here I write the boilerplate include dot h include stdil stdlib dot h int main RETUR and return 0. So now we'll see that what is binary search. Okay, so what is binary search? Binary search is more efficient algorithm for sorted arrays. Okay, so previously I say that binary search code is too complex than linear search. Okay, so you can see over here this is the binary search. Okay, you can see over here a array. Okay, you can see over here a array that is 1 2 3 4 5 6 7 7 element array. We have 7 element array. For example, we want to find the number 75. Okay, then we want to find the number 75. In this method we find the three portion in this array. First portion is left portion, that is first box in this array, and second one is the last box, that means right box in this array, and third one is the middle box in this array. Okay, so we first of all we find the three box in this array. How we will find? All of you know that array index starts from 0. So obviously the L, that means left box index number is 0. So if I write over here, if I write over here, if I write over here, this this element, this element is array of 0. Is it true? Right? Is it true? Because array index starts from 0, it is array of 0. Okay, so we found the first element of the array. Now we will found the last element, that means the right elements in this array. All of you know that last element is n minus 1. Here n is the how many element we have. Here we have 1, 2, 3, 4, 5, 6, 7. Here we have 7 elements in this array. So what is the last element of this array? That is n minus 1. That means the index number is 6. So array of 6 is our the top right element in this array. So now the question is how we found the middle element address. Size is equal to, you can see over here, for example, this is integer array. So integer element, how many byte occupy in the C++? It can vary in your compiler. Suppose I example in the C++, the integer is occupy 4 byte. Okay, so here the every integer occupy 4 byte. Here how many element in this array? How we know? We have a function that is called size, SIZD, size of array. When I write here, it will calculate the size of the total array. Here you can see 1, 2, 3, 4, 5, 6, 7 element. So 7 into 4, how much? Chapano, that means 56. So here it calculate 56. We divide with the size of array of index 0. That means the first element, that is the one element of this array. So uh, one element, one box, how many space occupy the one integer byte? That is 4 byte occupy. So here you can see the 56 by 4, how much? That is 7. So in this size we calculate the length of this array, that is 7. Okay, so finally we calculate the array size of this array. So here you can see what is the value of m, that is 3. So that is 0, 1, 2, 3. So there 36 is the middle element of this array. Okay, so first of all we have three condition over here. First condition is our target is 75. So we compare the 75 with m. If the 75 is equal to m, so first condition, so initially we easily found our target. So then we print a statement, that is we found the element, that is 75 and index number is 3. Okay, if we don't found the target in the middle, we have two conditions. If 75 in this side or 75 is in this side. So we have two condition over here. Sorry, our first condition is my target is equal to m. Our second condition is less than mid, it mean m, and we have the third one, that is my target is greater than m. So we have three conditions. If this one is satisfied, obviously we found our element and we will print it. Okay. If if it is not true, we check this part, that is our target. Here we spell the mistake, TRGET. Okay, T T. Okay, you can see over here, that is target greater than m. So if it is true, we eliminate those part, because in this part my target element is not exist. Okay, so the third condition is this, that is target less than m. If it is true, so in here we eliminate this term, because we know that in this part, in this selected part, my target element is not exist, so we can check this. For example, this one is true. Okay, so then what we will do, we shift the left, we move the left into here, that is m plus 1, because the index number of the m is 3. Okay, so here we assign L is equal to m plus 1. Okay, so now our left position is transfer in here, and this right position same as here. Okay, now we check the same condition over here. Our target is equal to m. It is true. If it is true, we print the 36. Okay, if it is not true, we check the same condition over here. The target is less than m, and similarly we check this condition. If it is true, we terminate this part, because here my element is not exist. Okay, if it is true, okay, so I eliminate those part, because here my element is not exist. For example, if it is this condition is true. For example, if this will is true, that is target greater than m. So then what we'll do, we eliminate those part. Okay, so we deleted those part, and finally we have one box in the last. Okay, so finally, and obviously it is must be our, I mean my target element, that is 75. Okay, now we apply in our code. Okay, so first of all we declare a array we declare a array, and the elements of these arrays are, for example, over here you can see over here, that is variable, that is size, and we add a function that is size of array. Then here we calculate the total size of the array, and it divided by size of the one element of the array, that is 0th position. Okay, so my size is assigned in the size variable. Okay, so here we write a target variable, and here we write a printf statement, and in the printf statement we write that enter the number which you wanna found wanna find wanna find what you to find. Okay, and here we write here slash n, and here we write a scanf for user input the number. Good. Then we'll create a function that is called binary search, SEARCH, binary search show. Okay, okay, so here we call the function that is binary search. Then here we write the definition of the function. So how many parameter how many argument we pass in this array? First of all, the we want our array. Second one is we want the size of the array, and third one is our target, that number which I search. Okay, so initially here we write a int, that is also array. Here we have another int, and done. Here we have three int, and here we receive the value, that is array. In array we receive the array value, we receive the size value in the size variable, and similarly we receive the target value in target variable. Then so if you remembered, that I say that initially we want three element, that is L, M and R. For example, if I write over here int, if I write here first element, that is also 0 because index number starts from 0. Here we write a last element, that is what I say, that is size minus 1. Here if here the size is 10, and size minus 1, that is 9. Okay, so last element is 9. Here we write a while loop and continue till, so when my L and R, that means the first element of the array, the first index number and last index number will be same. Then we stop our while loop. That means our work. So right over here, first less than equals to last. Right over here, mid int mid. I said that what is the value of mid? That is last first plus last divided by 2. Okay, here we write a sorry here we write a if condition because we have three condition that I say that this is three condition. Okay, so same here we write the three condition array mid. If the middle portion of the array is equal to our target. Okay, so here we have one sorry three condition. Here we write here the second condition. What is the second condition? Here we write else if condition and array mid greater than target. Here you can see the second condition and the final condition is obviously greater than condition. This is the less than condition and obviously the last one is greater than condition. So in the if condition what we will return. So if we found the our target in middle portion, immediately we return the mid index number. Okay, and here you can print and here you can print the middle index number value and you can print that I found the number. What we will return in here, we don't return because here we shift our left side to middle plus 1. So here we write first is equal to mid plus 1. Okay, so what we will write here, that is last is equal to same as mid minus 1. Okay, so if if this part is true, we eliminate this part and we transfer the r in here, that is m minus 1, that index position is 2. Okay, so same I write over here, that is mid minus 1. And if I don't found if I will don't find my number, okay, so what I will return, that is minus 1, that means false. Okay, so here you can see two types of return, that is mid and here minus 1. Okay, so here we receive the two types of return, that is mid for our target and minus 1 for we don't found our target. So here we write a result result is equal to this. So in in the result variable we store the value, that is mid or minus 1. Okay, so here I write here a if condition and in if condition we write here result is equal to minus 1. That means we don't found our target. So here we write oh don't for you found number. Okay, and here we write else condition. In else condition, right here printf the element element index number is percent %d and our index number it is result COLT result. Yes, found the number number. Here we give a slash n. Okay, so if I write a run this code, you can see over here, enter the number which you want to find. For example, we write here uh, 22. Yes, the we found the number and our index number is 1. So you can see here the 0 and 1, this is true. We run it again and here we enter 36. You can see over here, yes, our number is found, and here you can see the index number of 36, that is 3. We run it again and here we give a number that is 100. You can see over here, oh, don't found the number. Okay, so this is for today's guys. I'll provide you the all code in the video description. If you don't subscribe, please subscribe. Okay, so this is all for today guys. Bye.